Hello everybody, very warm welcome to Vedantu JEE English channel. This is me, your master teacher Nabamita Bhattacharjee. Quickly let me know if I'm audible and visible once, and I hope that you all are doing great. How are you all? Yes, quickly let me know if I'm audible and visible. Hi Swapna, welcome to the session. Hello. Yes, I am audible and visible. Yes, absolutely clearly, perfectly clearly. Yeah. All right, so good evening, very good evening. Hi, Bunny. Hello. Hi, HP24. Very good evening. So, quickly go call up your friends. Let's start with stoichiometry. A lot of calculations are going to happen. It's going to be very formula heavy, very data heavy session. So, be with me and let's try to unveil the mystery of chemistry a little bit today. Yes, very good evening, guys. Very good evening. Mama, hey, I'm not Mama, I'm Ma'am. That's fun, right? That's a typo, I'm guessing. Hi, Kavita. Hello. Very warm welcome, guys. Quickly go and call up your friends. Let's begin the session. Come on. All right. So, without much further ado, some basic concepts of chemistry. This is part 3. Basically, we are going to take a look at stoichiometry and stoichiometric calculations today. And if you remember in the last session, what are the things that we are done with? In the last session, we spoke about Dalton's atomic theory, atomic mass, molecular mass, average atomic mass, mole concept and molar mass, and finally empirical formula. So if you are not done with, yes, hi Meghna, hi, welcome to the session, bacha. Yes. Okay, now we are starting. So I'm not gonna take your name. I'm not gonna say hi and bye in the in between. Can I follow Vedantu Telugu? Yeah, sure. Why not? Who is asking? Who is saying no? You can. Definitely you can. All right, so these are the topics that we have completed in the last session. So if you did not know and if you are a little confused about these topics, then I suggest that please go back and check it out, okay? Because these are the very basics. If you do not know about these things, you might get a little stuck in the stoichiometric calculations, okay? So now, do you really know chemistry? No, bacha. I'm just pretending to know chemistry and I'm trying to ruin your life. That's what I want to do. Yeah? Do you want to ruin your life? Sure, you're most welcome here. Okay? Yeah. Anyway, so I think let's do a quick recap of some of the questions. Yes, let's do a quick recap of the questions and then we will start with stoichiometry and calculation. So, the first question is choose the molecular formula of an oxide of iron in which the mass percent of iron and oxygen are 69.9 and 30.1 respectively and its molecular mass is 160. So how do we calculate this, bacha? How do we calculate this? Does anybody know? Choose the molecular formula. You have to choose the molecular formula. Basically, what you have to do is you have to find out the molecular formula. So even if there are no options given, you can still do this. Okay. So what is given to us? What is given to us is that percent. Okay. Mass percent of iron. This is given to you. Am I right? Yes. This is given to you. Next, what is given to you is is 30.1. Right? These are the two things that are given to you, right? Am I not audible, director? Yes, am I not audible? Should I watch class 11 and 12 lectures if I... Yes, Madhukiran, you must. Yes. So these are the two things that are given to you, okay? Now what we have to find out is, we have to find out number of moles. Number of moles of iron. How do we calculate that? What we're going to do is, we're going to write here 69.9 divided by molecular mass of iron. Now what is molecular mass of iron? It is around 55.85, okay? 55.85. That is the answer. Okay. So that means that this will be equal to around, I think, 1.25. Can you calculate and check it out? Can you calculate and check it out, everybody? Yes? Okay. Now what we have to do is, we also have to find out the number of moles of oxygen is equal to 30.1 divided by molecular mass of oxygen is how much? 16.0. So this will be equal to 16, 15, okay. So it will be equal to 1.88, right? So the ratio becomes, yes, so the ratio becomes here, I filled up the whole this thing. Okay, let's write it here, huh? So the ratio becomes 1.25 is to 1.88. That means what I can do is, I can divide 1.25 divided by 1.25 is to 1.88 divided by 1.25, which will be equal to 1 is to 1.5. If I multiply both the sides by 2, I will get 2 is to 3. That means that my empirical formula becomes Fe2O3, okay? My empirical formula becomes Fe2O3. Now, but that's not the molecular formula. We are asked to find molecular formula. So, how do we do this? How do we do this? What we are going to do is, basically you multiply empirical formula with a factor called N. Now, what is N? N is basically the given molecular mass divided by the molecular mass of the empirical formula. Okay, what is N? N is equal to given molecular mass divided by molecular mass of EF, that is empirical formula, which is nothing but 160 divided by 160. For Fe2O3 also it is 160. So N becomes 1. What is our N? N becomes 1. Now if I multiply 1 with Fe2O3, my answer is also going to be Fe2O3. Did I make sense, guys? Did you all understand how to calculate this or not? Hello, I don't see any chat. Director, I think I've already explained that dropper batch. No, mentor, if they haven't called you, you are supposed to start with your batch. Please take a look at the timetable of the batch. Okay, please look at the timetable of the batch. Otherwise, I'll anyway let the team know that you did not receive a call. ठीक है. अच्छा, how many of guys haven't you started with your JEE preparation yet, or have you? How many of you are 11th standard here? All of you are 11th standard in this channel. Can you find out? Can you find out? You are in 9th. Meghna, what are you doing if you are in 9th standard? Why are you here in 11th standard? You all are from 11th standard. Swapna, you are from 12th standard. So you have forgotten your 11th standard basics, is it? Is that why you are here? You are in 11th. Okay. All right. All right. Okay. You were a diploma student in 12th. Okay. All right. Okay. Because I do let students know in Telegram channel and everything, but I still see that students are not coming. Anyway, moving on to the next question here. The next question, everybody, is the density of a gas is 1.78 gram per liter at STP. You have to find the weight of 1 mole of a gas. All right, let's do this. So this is going to be simple, right? This is going to be simple. So the density of a gas is given to you and it is written that at STP. Now at STP, what is the volume? The volume of gas, if you remember, is 22.4 liter. Do you remember, guys? Do you remember this? At STP, volume is equal to 22.4 liter. All right. Yes. And density is already given to us. Density is already given to us. It is 1.78 gram per liter. All right. So volume is given to us, density is given to us. We have to find the mass, right? So that means mass is equal to volume into density, which is equal to 22.4 into 1.78. So if I consider this 2 and this is 20, answer should be equal to around 40. I think the answer has to be equal to almost about 40. So I think option A makes sense to us because 39.9 is almost 40. So I think this is the correct answer. What do you all say? Make sense? Calculate and let me know if this is correct. Calculate and let me know if this is correct, guys. See. Check it out. Journey to IIT. Bacha, listen to me very carefully. If you are thinking that I'll give you a piece of gossip. Number one, I would have actually spoken to you very well. I would have said hi to you and everything. But it looks like you are here just to show a little bit of attitude, and you are here to show that you are, you know everything very well. So, if you're thinking that I'll give you a piece of gossip, no. I'm a teacher and I will support another teacher also. Okay? So, secondly, haven't you noticed that anybody who works in private sector does change their job after 3 to 4 years? Have you noticed that? Yes? So, just like that, they felt that they wanted a change in their life. So, they have moved. Yeah? So, don't ask for a gossip. There is no reason to it. They felt there was a change necessary. They changed. So all of us do have the right to change our company. Okay? Alright? So don't ask all these reasons. There is no reason. Nobody has had a fight with somebody. Nobody dealt with something else. Okay? People just move on. That's it. That's what happens. So journey to IIT, I hope that I have explained. And please be humble, modest. Don't be a show off. Yeah? Don't be a show off. Don't do that. Alright? Okay, so everybody, let's now start with our today's topic, that is stoichiometry and stoichiometric calculation. First of all, there are a lot of pronunciations that you will find everywhere, but the correct pronunciation is stoichiometry. What is it? Stoichiometry. All right? Yes. Now, moving on from here, what exactly is stoichiometry? So if you just, if a person is just passing by and if you say, excuse me, can you tell me what is stoichiometry? You should be able to do that. You should be a layman on the road walking by and you should be able to say what stoichiometry is. So stoichiometry is actually nothing but just the calculation of masses of the reactants and the products. So when you write a chemical reaction, what happens? What is it that you see? You see reactants on one side. You see product on one side. Right, everybody? You see reactant on one side and products on one side. So basically, what you're doing in the stoichiometric calculation is you are calculating the masses of the reactants and the products that are involved in a balanced chemical reaction. Now, obviously, there are different methods for you to be able to calculate, right? There are different methods. Two of them I have noted it down. One is mole method and the other one is principle of atom conservation, that is POAC method, okay? These are the two methods that I think most probably if you get a question like from here, from this topic in your JEE, then probably it will be from one of these methods. There are different methods also, okay? Not saying that there are no different methods. There are different methods as well. There is another method called SIRF method, which I think I have it listed in one of the questions, so we will do that. Yes, but there are two methods, that is mole method and principle of atom conservation, that is POAC method, that we are going to do right now, okay? All right. So let's start with the mole method. in the mole method, right? In the mole method, what happens is, what is very important is balancing of the chemical equation becomes very important. Okay. What did I say? What did I say? Yes, this topic does contain good weightage, Rohan. Yes, this topic does contain good weightage. Give me a minute. I am feeling a little thirsty. Need to drink a little bit of water. Okay. So what did I say, everybody? I said that the mole method needs you to balance the chemical equation. Okay. All right. Will you complete the syllabus for JEE 2024, both 11th and 12th? Journey to IIT, bacha. Please understand that this is a YouTube channel, right? So, I am not just teaching here just like that, right? Yeah. So, if I am teaching you here, obviously it is for JEE 2024. And because it is a YouTube channel, it is very important for us to make sure that we have the right credibility. So of course, I assure you that we will be completing the syllabus for both 11th and 12th for JEE 2024. Yeah, stay tuned. Don't worry about things. Everything will get sorted. Yeah, like I said that I am planning for a series wherein we will be completing the 11th syllabus in just 1 month. I am planning that. I have almost made the content how to teach and all of this. So, but that will be recorded content, so that there are no disturbances. No one is talking to you like this. Yeah, and you can just sit and just complete the syllabus and revise, right? So that I am going to do very soon, and I will upload it. Okay. All right. So now, what did I say, everybody? That in the mole method, coming back to the point, everybody come back. For mole method, what did I say? I said that balancing of chemical equation is very important. Balancing of chemical equation is important. Now, shall we take this thing? Shall we take a example? Let's take is this balanced now? Is this balanced? No. So we will have to balance it, right? How do we balance it? Now see, how do we solve this here? Okay, very simple, very easy. What we can do is, okay, all right, that's what we are going to do. Moles of KClO3 is equal to now. Just see it once and see if you can understand. Do you understand, everybody? So in the mole method, balancing of chemical equation is very important. Only thing that we have done is moles of KClO3 divided by the coefficient. That's it. Just divided by the coefficient. That's all that we have done. And that's how you solve it. That's how you solve it. Clear? Yes? Now let's do the second one. What is our second one? Second one is POAC. That is principle of atom conservation. What is POAC? POAC is principle of atom conservation. Principle of atom conservation. And in this one, balancing of chemical equation is not important. Okay, all right. So now in this case, how do we do it? Let's take the same example, KClO3. Heat it up, you get 2 KCl plus 3 O2. Yes. Now check it out how we can do it. Okay. Even if I don't balance it, right? Even if I don't balance it, and if I just write the reaction like this, okay. Let's write it down here once again. KClO3 gives you KCl plus O2, right? Even if I don't balance it, just check it out how I can write it down here. I am going to change the color here and write it C. POAC of K. POAC of K. See, 1 mole of KClO3 is giving you 1 mole of KCl. Am I right, guys? Coefficient is 1, 1 in both the sides. And for KCl also it is 1. Correct, everybody? Are you with me? Are you with me? POAC of KClO3, 1 coefficient here, 1 is the coefficient. Both the sides are 1, 1. Right? Great. So, write POAC of K is 1 mole of KClO3 is equal to 1 mole of KCl. Okay. Now, POAC of Cl, if I do, again 1 mole of KClO3 is equal to 1 mole of KCl. Yes. Now, POAC of oxygen, if I do, check it out. POAC of oxygen is equal to what? This will be 3 mole of oxygen is giving you 2 mole of oxygen. Do you see? What do we get here? We get 3 mole of KClO3 is equal to 2 mole of O2. Yes, 2 mole of O2. Did you understand? Is this clear, guys? This is how we solved POAC. This is how we solve POAC. Is this clear, everybody? Principle of atom conservation. Yes, this is how we do it. Everybody understanding or not understanding? Come on, clear it out. Hi, Chakram. Welcome, welcome. Yes, guys, let me know, let me know. Okay, shall we move on from here? Shall we move on from here now? Or no? Yes or no? La la la, EPBT, great. Okay. Now moving on from here, we see something called as limiting reagent. Okay, mole method is easier. Not understanding. Acha. So I'll give you a question. I think then you will understand. I'll give you a question. I think then you will understand. So okay, let's check it out again. For mole method, you had to balance the chemical equation, right? Once you balanced, all you had to do is moles of KClO3, you divided it by the coefficient. This is your coefficient, just divide it. Just divide it, okay? Alright, that's how you solve it. And basically what they want to say is, these ratios are supposed to be equal. So if you are given a stoichiometry problem and if you are asked to find out something, basically stoichiometry problems will be related to limiting reagent, excess reagent. And there will be other questions as well, right? In the 5th session of this mole concept, we will be solving at least 50 questions. I've already asked my SME to make the content and I have given her questions also from Narendra Awasthi's book. We'll be solving all of that. So please stay tuned, okay? Don't miss out, right? Apart from this, now in POAC, we did not balance it. But do you see how we have equated? See, for here, the coefficient was 1. In case of KCl, do you see any other number? But everything is 1, 1, right? Journey to IIT, do you see? But in case of oxygen, in this case, do you see that there are 3, for O3 it is written. So what we have done is, actually there should be a multiplication sign here, okay? There should be a multiplication sign. So it should be 1 into mole of KClO3 is giving you 1 into mole of KCl. 1 into mole of KClO3 for Cl. When we are finding the POAC of Cl, chlorine, we see that 1 into mole of KClO3 is giving you 1 into mole of KCl. But in case of oxygen, we see that 3 into mole of oxygen is giving us 2 into mole of oxygen. 2 into mole of O2 on the other side. So basically what we are doing is we are equating the reactant to the product side. That's it. That's it we are doing, right? Yes. Now we come to limiting reagent. Read the statement once. What's the statement? The statement says that the reactant which is completely consumed in the reaction and limits the amount of product formed is called as limiting reagent. If we did not understand, let's take a very simple example. Let's say that, guys, I'm asking you to make sandwiches. I'm asking you to make a sandwich. Not just any sandwich. I want you all to make grilled cheese sandwich. Oops, hungry now. Grilled cheese sandwich. So how are you going to make a grilled cheese sandwich? You are going to need 2 slices of bread, 1 slice of cheese, grill it in the sandwich maker, and lo and behold, you get your sandwich, right? Yes. Now, how many slices of bread do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 slices of bread, and do you see that I only have 1, 2, 3 and 4 slices of cheese? Yeah. But I do need, if I want to make sandwiches, I will be needing more amount of cheese as well, right? So I am only able to get 1, 2, 3 and 4. 4 number of sandwiches, but I did have another pair of bread, which came out as it is because I had less number of cheese. Once again, everybody, because I had less number of cheese slices, did you see that the process of making the sandwich actually got reduced? It was stopped. Somebody refrained me from making the sandwich, and who did that? It's the cheese slices that stopped me from making as many sandwiches that I wanted, right? Now, in this scenario, can you tell me which one is the limiting reagent? Easy peasy, biryani tasty, it's the cheese. The cheese is the limiting reagent. This is our limiting reagent. Yes? And which one is our excess reagent? The bread is the excess reagent. Yes? The bread part is the excess reagent. Now, coming back to the definition, do you seem to understand it now? What does it say? It says that the reactant which is completely consumed in the reaction. What did we see? We saw that the cheese part actually was completely consumed in the reaction. Yes, there was not a single slice of cheese that was left for us. We only had 4 cheese slices and all of it was consumed in the reaction. And it limited us from making 5 sandwiches. We could only make 4 sandwiches because we did not have the 5th cheese slice. Easy peasy biryani tasty. Now let's use this analogy in a chemical reaction. Take a look at it, okay? If we do not have a limiting reagent, let's say for this reaction, yes, if I take 3 hydrogen here and 6 gram, and then if I take nitrogen of 28 grams, I should be getting 34 grams of NH3. In the absence of limiting reagent, right now there is no limiting reagent, okay? Right now there is no limiting reagent. Whatever I have taken hydrogen is getting consumed and producing NH3. Yes? Alright? Yes? Now take a look at it, everybody. What if I take 1.5 hydrogen of 3 gram? 3 gram 1.5 hydrogen. And I still take the same amount of nitrogen, that is 28 grams, okay? I still take the same amount of nitrogen, that is 28 grams. This time, do you see that it is so much in less amount that it will get completely consumed, but it will still not be able to produce 34 gram of NH3. It is producing only 17 gram of NH3. And if you subtract 17 from 28, what will you get? You will see that 14 gram is still remaining. That becomes the excess reagent. That becomes the excess reagent. Yes? Chakram, you did not understand. Chakram, see. Okay? Chakram, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces of bread. Okay? And I have asked you to make sandwiches. For each sandwich, you will require 2 pieces of bread. Yes? And I have given you 4 slices of cheese, and I'm saying that go crazy, make as many sandwiches you want, okay? But you were only able to make 4 sandwiches. Later on, I come back and I start scolding you that why did you not make why did you not make 5 sandwiches? I gave you 10 pieces of bread, and then slowly you tell me, but ma'am, there were only 4 cheese slices. Because the cheese slices were less, it limited your Sandwich making process. You wanted to make more sandwich, but you could not make more sandwich because cheese slices were less. So the cheese slices are called as limiting reagent because it limited you from making as many sandwiches you wanted. And you saw that the bread was the excess reagent because the bread was remaining as it is even after the whole reaction was completed. Even after the whole sandwich making process was completed, the bread was as it is there. So that's your excess reagent. Got it? Similarly, now if I use the same example in a chemical reaction, okay? Everybody understanding, guys? Yes? No. Journey to IIT, please don't do this, bacha. You know what? I'm not gonna see your messages. You're disturbing a little too much. I'm sorry, but you might be smarter. Not everybody is as smart as you, okay? Don't do this. Please don't do this. That's why I told you that you are here only to show off. Please don't do that. If you are here to abuse me, scold me, do that and go. Please do that and go. No worries. But don't disturb the class like this. There are probably definitely students who are learning for the first time, who are here in class 11 for the first time, who have probably opened the book of NCERT for the first time. I can't do that to them. Okay? So if you want to abuse me, scold me, you want to do that, get it out of your system and go. No worries about it. I mean, I teach on YouTube. This is an everyday thing. Every day, people throw abuses like this at me. It's fine. I'm okay to deal with it. But please don't do this. Not again. That was your last warning. One more time, if I see you commenting something like this, I will remove you from the channel directly. Okay? Yeah. Alright. Now, coming back to it, everybody. What did I say? Absence of limiting reagent. Now, let's say, Chakram, that imagine if there is no limiting reagent. Okay? There are no limiting reagent whatsoever. Yes? I have taken equivalent amount of hydrogen that is required for this reaction to get over. So, I have got 34 gram of NH3. Yeah? I have got 34 gram of NH3. But, if I did take very little amount of hydrogen but same amount of nitrogen, then I see that the process was being limited by someone. Somebody did try to stop it. Yeah? Yes? So, NH3 formed here was 17 gram only. Whereas in the previous reaction, we saw that 34 grams were formed, but here only 17 gram was formed. The remaining 14 gram, it remained as it is. It was not utilized only. So, that became our excess reagent. Understood? Clear? Okay? Great. Amazing. Now, did you know that for limiting reagent, what you can do is, you have to divide the given moles of each reactant by their stoichiometric coefficient. The one with least ratio is limiting reagent. Let's say that I have a reaction here. Let's say that it is A plus B gives you AB, and you are told that given A has 2 moles and it is given to you that B has 3 moles. Okay? Let's say that we have a reaction A plus B gives you AB, and it is given to you that A has only 2 mole and B has only 3 moles. So, as per this rule, the rule says that divide the given moles of each reactant by their stoichiometric coefficient. What is stoichiometric coefficient? That means here it is 1, here it is 1, here it is 1. So, what I am going to do is my limiting reagent. Who is the limiting reagent? I have to decide. Yes, I have to decide which one is the limiting reagent. So, now see, journey to IIT, you are telling me that you know everything, you understand chemistry, only I cannot make it easy. See what students are asking. Stoichiometric coefficient, very basic, right? You are supposed to know it. What happened now? Huh? What happened now? Anyway, HP24, bacha, this is called as stoichiometric coefficient. What I wrote here, 1, 1, this is the stoichiometric coefficient. Okay? Yes, this is the stoichiometric coefficient. Got it? For example, in this case, 3, this is the stoichiometric coefficient. This is the stoichiometric coefficient. Understood? Yes. Got it? Okay. Chalo. Moving on from here now. So, A is given. It is given to you. I'm just saying, I have just formed a question right here. Okay. So let's say that A plus B is giving you AB. A is 2 mole, B is 3 mole. That's given to you in a question. So what we are going to do is, we are going to do that, okay, for A, what we can do is 2 divided by 1 is equal to 2. And for B, if I do, then for B, 3 divided by 1 is equal to 3. Now that means, which one is the lesser number, guys? Which one is the lesser number? Is 2 a lesser number or 3 is a lesser number? Which one is a lesser number? Tell me. Is it 2 or 3? 2 is a lesser number. So behold, this is our limiting reagent. That means that A is our limiting reagent. This is our limiting reagent. Alright. This is our limiting reagent. Clear? Yes? Clear, everybody? Make sense? Nonsense? So A is our limiting reagent. A is our limiting reagent. Got it? Yes? Works? Shall we move on? Shall we move on then? Okay. Alright. Amazing. Now here is another question. Okay. Now we are going to take a look at the SIRF method. SIRF method. It's okay. It's okay. Journey to IIT. No problem. It's fine. It's fine. It's fine. Anyway. Now here is another question. 3A plus 6B gives you 3C plus 5D. These two are 0, 0. 3A is 9 moles, 6B is 27 mole, and you have to find out the limiting reagent and number of moles of products. Okay, you have to find out number of moles of products. So let's do it. Now we can take care of the SIRF method, that is stoichiometry, initial amount, reactant amount, reacted amount, and the final amount. What did I say? I said that SIRF method. SIRF method. This is also another stoichiometric method. Like, you know, we did that mole method, POSE method. This is another method, SIRF method. What is it? Stoichiometry. Stoichiometry. Initial amount. Reacted amount. And final amount. So now, oops, what happened? I think we are here. Okay. Now what we can do here is, for the SIRF method, what exactly can we do? Check it out here. Okay. So there is something called as there is some factor called as K. Okay, there is some factor called as K. So for K, what we do is, say what is the stoichiometric coefficient and what is the given mole. So given mole divided by stoichiometric coefficient. So when you do this, for K for A, the K value for A will be, check it out, 9 divided by 3, which is basically 3. Yes. And K for B is what? 27 divided by 6. 27 divided by 6 will be, K is a factor, bacha. It is a factor, okay? It's a factor. Hi, Somesh. Hi, Somesh. Thank you so much, yeah. 27 by 6, if you do, I think it will be around 4.5. Yes. So now tell me, which one is the limiting reagent? Which one is the limiting reagent? Obviously, A is the limiting reagent. A is the limiting reagent. Alright. Now, see, focus right now. Chakra, focus right now on how to find the limiting reagent. When the right time comes, I will tell you what is K. I will tell you what is what. Everything. Don't worry about it. Yes. So is this clear, guys? This is the SIRF method that we did. This was also very easy. We can easily find out what is the limiting reagent now in a solution, in a question. Can we or we cannot? We can, right? Okay. Moving on from here, now we come to something called as percentage yield. So whenever a reaction happens, we also do want to find out what is the yield, that is how much of the product is produced, right? For example, you know what happens? Let's say that I ask you that, hey, everybody do join Vedantu. Vedantu has an amazing course and everything. You're going to ask me, what is the yield of result? Right? You're going to ask me, what is the yield of result? And by that you want to ask me that how much result have you produced? Right? And then I'm going to say that AIR 21, AIR this, AIR that, AIR 1400 something, AIR 1300 something, AIR 2000, AIR 200 something, AIR 100 something. All of these ranks have come, right? Yes. So percentage yield of product means how much percentage of the product have we produced. Yes. So how do we calculate that? Any idea, guys? Come on, let's see. Any idea, everybody? Let's check it out. Who can tell me this? Achha, by the way, please tell me that you are able to, you are able to hear me, because the mic is stuck on a chair today. I'm not sticking it to my t-shirt. The other day there was a lot of sound issues. So please let me know if you are able to hear me properly. Just gonna move it a little this side. I'm drinking water. I hope it should not fall on the mic. Tell. Come on. Audio is clear? Alright. Okay. So the percentage yield of product, basically it's a very small chottu formula. There's nothing much about it, okay? It's very small chottu formula. The what is it? The formula is into 100, okay? Basically what we mean to say here is actual yield, that is how much actually we have produced, divided by theoretically what is the maximum yield that we calculated, and then you multiply it with 100, obviously, because we are talking about percentage yield of the product, right? What we are talking about? We're talking about the percentage yield of the product. So obviously multiplied with 100 is necessary, right? And now we come to a very important part, and this part is also required in class 12. So please be very focused right now so that you can understand all of it. Concentration of the solution. See guys, you have to understand that whenever we take a solution, right? In a solution, there are two parts, correct? In a solution, normally the solution that we are probably trying to make it at home has two parts. And most of the time we call them as binary solution, where there is one solute, one solvent, which is equal to a solution, right? Now what if you want to increase the solute in the solution? If you start increasing the solute in the solution, what happens? Concentration increases. Yes, concentration increases. And when concentration increases, you can either say that the solution is concentrated or dilute. But like I said in my yesterday's session of solution, I told you that it's a very vague term. Quantity wise, you are not saying anything, right? It's a very quality oriented, concentrated, dilute, that's it. We're talking about science. Hey, we need precision. And that's when we came up with concentration of the solution. So there are different ways that you can express the concentration of the solution, and the first one is obviously mass percent. Okay, first one is obviously mass percent. So how do we write mass percent? Very simple, very easy. What do? We write that mass of solute divided by what? Divided by, tell me guys, mass of solute divided by what? I have told you this yesterday also. Anybody who can tell me this? Anyone who can tell me this, guys? Come on. I've told you. Sapna, I'm hoping that you will be able to tell me, because I told you this yesterday. Mass of solvent. No. Mass of solution. Mass of solution. Yes, Rakshana. Very good. It is Mass of solute divided by mass of solution multiplied with 100 because percentage is there. Okay, what is the symbol here? The symbol is W divided by W. Okay, this is your symbol. Now we come to mass by volume percent. Tell me, did any one of you notice ever that in your cough syrup this kind of numbers are written? See, W by V is written. Can you see? Can you see here? Can you see? I don't know if you can see, but it is there. Lactitol monohydrate syrup 66.67% W by V. What does it mean? It means mass by volume percent. It means mass by volume percent. And what are we doing here? What we are doing here is mass of solute divided by volume of solution. This you take it in liter or in DMQ multiplied with 100. Okay, all right, yes, all right, chalo. You don't like it? Okay, all right. Now we come to volume percent. Volume percent is also going to be same. Volume percent basically has volume of solute divided by volume of solution into 100. Easy peasy? Yes? Yes, easy peasy, guys. Do we understand all of this or not? Do we understand all of this or not? Come on. Yes? Okay. All right then. Moving on. Now we come to another term called mole fraction. Now see, mole fraction is basically, okay, yes, bacha, mole concept is the base for all physical chemistry chapters. Yes, even if you are doing solutions, even if you are doing solid state, you will be requiring this. Okay. Now, so chi, mole fraction is always denoted. This might look like X, but this is not X. This is what? Chi, C-H-I, chi. Okay. So chi of solute will be moles of solute divided by total moles of solution. Yes. Now when we come to a chi of solvent, what will you do? Moles of solvent divided by total moles of solution. And we know that because it is a fraction, so solute plus solvent is supposed to be 1. This is very important. Okay. Now moving on to molarity. Molarity is another way to express concentration. Molarity is given to you as a capital M. Capital M is equal to number of moles of solute divided by volume of solution. So mole fraction, what we did was mole by mole, mole of solute by mole of solution. In case of molarity, what you do is you take mole divided by volume. And then we come to molality. Molality and molarity is different. Molality is denoted by small m. And in this case, what do we do? Tell me. In this case, what do we do? In molarity, volume can be expressed in milli. Yes. However, mostly you try to, interchange this. Yes. Okay. Venkatesh. This you understand this? Virtually also you'll get this. Okay, molality. I have explained this yesterday also. Can somebody tell me this is denoted by small m, guys? Small m. Tell me. Very simple, very easy. Chalo. Number of moles of solute, I have written that now. Now what? Now what? Very good. Very good. Number of moles present in 1 kg of solute divided by weight of solvent. Is it true? Is it true what Tiger is writing? Is it true, guys? Tell. No one is telling. This is the formula, okay? Now moving on to parts per million. What is parts per million, bacha? Parts per million is very easy. It is as equivalent to mass of solute by what? Solvent or solution? Solvent or solution? Yes, tiger, I'm hoping that you will tell me the answer. Okay. Let's not waste time. Let's not waste time. Now this time what are we going to multiply it with? What are we going to multiply with? We are going to multiply it with 10 to the power 6 million. No longer any percentage is needed. So 10 to the power 6. That's going to be our answer. By the way, be very careful. This is only used when there are trace amount of solute present. Okay. Trace amount of solute is present. Okay, that's when we use this 10 to the power 6. Okay, now let's do a problem, guys. Calculate the molarity and the molality of a 98% by mass of H2SO4 solution having a density of 1.25 gram per cc. Any idea how we are going to start with? Any idea how we're going to start with, guys? We have to calculate the molarity as well as the molality. Chalo, let's think about it. Can someone tell me how to start with it? How are you going to start with it? Think. Moles. Wow. So vague. Ma'am, we're starting with moles. What is given to you? 98% by mass of H2SO4. Okay, what is given to you is 98% by mass. H2SO4, which means that in 100 gram, the moles of solute, tiger, we have moved out of it. So if 98% by mass of H2SO4 is given, that means that in 100 gram of solution, 98 gram H2SO4 is there, right? That means that 100 gram of solution Alright everybody, this much is understand? ppm again, ppm I have said that when there is very trace amount of solute but the solvent is in huge amount, okay, what we do is, what we use is parts per million. So you take mass of solute and then divide it by the total mass of solvent, then multiply it with 10 to the power 6. That's it. Okay, all right. Shall we move on then? Is this clear? Tiger, bzzz. That's your name, right? I will explain it. Don't worry, I am planning a lot of questions. Yes, very soon we will do it. But I thought that in 3 parts we will be able to complete the chapter. But guess what? We are not. We will not be able to. Because after today's session also we will still be left with dilution, normality and all of that we will have to continue in some other session, okay? We will have to continue that in another session. So I will require at least 5 sessions for me to be able to complete this whole chapter. Menti quiz, Chakram, we don't do menti quiz and all here. Yeah, here is more important to solve the questions. So let's solve the questions, okay? All right. So now we have understood that 98% by mass of H2SO4 means 100 gram of solution consists 98 gram of H2SO4. Now if I ask you what is the mass of the solution, then what is the mass of solution? Mass of solution is 100. Mass of solution is 100 gram, right? Mass of solution is 100 gram, correct? Yes. What about mixing of solutions? Will we cover this? No, bacha, mixing of solutions we will not be able to cover in today's session. We will be covering it in the next session, okay? We will be covering it in the next session, okay? Is equal to 100 gram. Mass of solution is equal to 100 gram. Now, what is mass of solute? Mass of solute is given to us. Yes, tell me what is mass of solute? How did we get mass of? Bacha, what is given? 98% by mass. 98% by mass. Now remember it. Mass percent. What was mass percent's formula? What was mass percent's formula? Do you remember? Let me show you once again. Mass percent formula. See, mass of solute divided by mass of solution into 100. Yes, mass of solution. So from here we understand that our mass of solution has to be 100 gram. Okay, we have to understand that it is 100 gram. Darun, you have already solved it. Very good. Very good. So our mass of solute is 98 grams here. Correct? That is given to us, right? So what is our mass of solvent then? What is our mass of solvent? Very easy. Gram, right? 2 gram, which I can also write it as 0.002 kg. Can I do that? Can I do that? I can, right? I can I? You guys, wake up. Everybody, sleeping or what? Don't sleep. Chalo. Till here everything is clear? Till here how we got it, everything is clear? Okay, great. Now what we're going to do is, now we're going to find out, moles of the solute. Okay, now we're going to find out moles of solute. So given mass is 98 divided by molar mass. What is the molar mass of H2SO4? Molar mass of H2SO4 is also actually 98, which means that moles of solute is definitely basically 1. Okay, all right, yes, it's definitely 1. Now what do we have to calculate? We will be calculating the volume. Okay, we will be calculating the volume of solution. Volume of solution will be equal to, any idea? Chalo, let me know how to solve it. Let's see if anybody can tell me how to go around it. Volume, everybody, volume of solution. I really hope that you know the formula of volume, guys. How do you calculate volume? Mass by density, no? Nobody said anything. Very disappointed. What is volume of solution? Yeah, mass by density. Mass by density. So what is the mass and what is the density? It's all given to you. Hey, what is the mass? Mass of the solution is 100, right? It's 100. And what is the density? 1.25. 1.25. So what that is equal to 100 by 1.25. Do it and tell me. 100 by 1.25, how much will you get? Chalo, let's do it. I have to use my phone, but you don't have to. 80. Yes, 80 is the correct answer. So we get 80 ml, which is equal to, which is equal to, is that right? That's right. Yes. Okay, so now we have found the volume. Now next what do we have to do? Now we have to figure out the okay. Now we have to find out. Acha, the volume we have figured out from mass and density. Okay. Now what do we have to do? We can calculate the molarity, right? We can calculate the molarity. So how do you calculate the molarity? How will you calculate the molarity? We just did the formula, everyone. What is the molarity formula? Tell me. What is the molarity formula? LK, this is for 2024 as well as 2025, okay? For 2024 as well as 2025. So tell me, molarity is moles of solute by volume. Yes? Moles of solute is 1 divided by 0.08. Could you please calculate this and tell me? Could you please calculate this and tell me? I think now you were right. Yes, it will be 12.5 molar. Absolutely right. Okay. Now what do we have to do? We have to find the molality. Molality will be moles of solute by what molality? Moles of solute by mass of solvent in kg. What is the answer here? What is the answer here? 0.002 or 0.002. 500. Very good. That is the correct answer. Okay, that is the correct answer. Is this clear, guys? Is this clear how to solve it? If you are getting a question like this, then this is how you're going to solve it. Okay, I'm sorry, my mood went a little off after looking at all those chats that were there. I mean, you really try not to look at these chats, but somehow or the other, you know, you just get to see it and then it just spoils your mood. Anyway, coming back to it. So there are some important relations that we have to know, okay? The important relations are, do you remember in yesterday's session, I gave you a problem and we tried to solve it? Do you remember? Relation between molarity, density of solution and molar mass of solute. Do you remember? We did do a question there, if you remember. By chance, by any chance, do you remember, guys? What was it? So basically what you do is molality, which is denoted in small m, is equal to, does anybody remember? Swapna, I hope that you remember. No? Yes? 1000 into capital M, that's molarity, divided by 1000 D minus M into MO. M is again the molarity and MO is the mass of solute. Yes? Now let's do a question and let's try to solve it. Repeating the same question here, can we figure this out, everybody? Can we figure this out? A 6.50 molar solution of KOH. So once again, let's do it here. See, M is equal to 1000 into M divided by 1000 D minus M into MO. Here, M is equal to 6.50, that is given to us, 1000 M. So let's just write it 1000 M here. Now 1000 into D. D is what? 1.89. So it means that this is 1890 minus M. M we still do not know, but we know that M naught, that is the mass of the solute. Solute is KOH. So 39 plus 16 plus 1 will be 56. Yes, it will be 56. So M into 56. Now what we are going to do is multiply this with this. Okay. Multiply this with this. What will you get? So check it out. 6.50 1890 minus 56 M is equal to 1000 M. Can you calculate this, everybody? Calculate this and tell me. Calculate this and tell me. Is that correct? It is 8.98 something. So that means almost equal to 9. That is the answer. This is how you, yes, very good, Bacha, very good. So this is how you calculate, okay? This is how you calculate, yes. Right. Now moving on, here is another relationship between the molality M and the mole fraction, let's say chi B, okay, 8.999, yes. Mole fraction chi B of the solute. How do we do this? How do we do this? So basically what we are going to do is again molality. So small m we will write, okay. Small m is equal to chi B divided by 1 minus chi B, okay. Divided by 1 minus chi B. That's how we can do it. That's also very simple, very easy, right? Very simple, very easy. But here is multiplied with 1000 divided by, I hope I'm writing it right, by molarity of A, okay? Because you know that there are, if it is chi B, that means there is also chi A, right? There is also chi A, because in a solution there is always a solute and a solvent. So there has to be chi B and chi A as well. So if there is chi A, then molarity of A will also be applicable here. Understood? Yes, everybody? Now, there are certain points to remember. So, do you see that I have showed you a lot of formulas, isn't it? I have showed you a lot of formulas. Now, molarity is the most common unit of measuring the strength of the solution. Do remember it. In most of the cases, you will see that molarity is being used, molarity is being used, molarity is being used. Correct? Now, the product of the molarity and the volume of the solution will give you moles of the solute, which is obvious, right? Yes. So, the product of molarity and the volume of the solution will give you what? It will give you moles of the solution. Okay? Yes. Now, see, this point is very important. Just read it, guys. All the formula of strength have amount of solute, weight, or moles in the numerator. You want to check it out? Let's check it out, everybody. Let's check it out. See, mass of solute, number of moles of solute, moles of solute, moles of solute, volume of solute, mass of solute, mass of solute. Did you just see? Everywhere in the numerator you actually have only moles of solute or mass of solute. Doesn't that make our job simple now? Doesn't that make our job simple? So now if you write the formula right in front of your eye and if you keep taking a look at it, my dear students, within 2 days you will be able to learn all these formula by heart. In a snap you will be able to do the problems if you just write it down. Next, all the formula, they have amount of solution in the denominator except for molarity. What do they have? They have amount of solution in the denominator. You want to check it out once again? Let's check it out. See, oh, parts per million also no. Molarity has mass of solvent in kg. Apart from this, now see, volume of solution, moles of solution, volume of solution, volume of solution, and mass of solution. So did you see? Everywhere they are talking about the mass or the volume of the solution in the denominator except molarity and parts per million as well. Yes, I will be sending you the PDF in the Telegram channel. Alright everybody, got it? So now we come from here, we come to dilution law. What is dilution law? Like I just said, if there is a solution, then obviously what you can do is you can always increase the solvent part, right? Now tell me something, if I increase the solvent part, does my amount of solute change? No, it doesn't. And when I'm diluting a solution, what exactly I'm doing? I'm obviously adding more solvent. When I'm concentrating the solution, what am I doing? I'm adding more amount of the solute. But when I'm diluting, I'm adding more amount of solvent. And when I'm adding more amount of solvent, the moles of the solute, yes, we can, definitely. The moles of the solute, it remains unchanged. You don't change it. So if the volume of a solution has a molarity, let's say M1. Let's say that I have a solution. Let's say that I have a solution here. I have a solution here. And the molarity of this solution is, M1. And let's say that the volume of the solution is okay. So what will happen? I definitely probably will add more amount of solvent and change the volume. I'm only changing the volume from V1 to V2. But am I doing anything with the solute? Nothing at all. So the moles of the solute, my dear students, it remains unchanged. It remains as it is. So M1 V1 will be equal to M2 V2, that is because moles of solute in the solution remains same. Once again, if molarity is M1 and volume is V1 for a solution, and if I change the solvent, amount of solvent, that is I increase the amount of solvent and I change the volume to V2, it will still be M1 V1 is equal to M2 V2. Do I make clear? Do I make sense, everyone? Do I make sense, guys? Yes or no? Yes. Okay. Now, what is the effect of temperature on concentration? The effect of temperature on concentration is that, understand this, molality and mole fraction are mostly preferred over molarity. We don't want to take a look at the molarity, we rather want to calculate the molality and the mole fraction, because molality and mole fraction, they do not depend on the volume. Now molarity depends on the volume, and what happens is volume can change when you change the temperature. If you increase the temperature, volume will increase, right? Yes. So with temperature, volume changes, and that is why instead of going for molarity, we tend to focus on molality and mole fraction. That's exactly what is written here, which you can read later on. Okay. Now here is a question that has come in the JEE main, so let's try to solve it. For per gram of reactant, the maximum quantity of N2 gas is produced in which of the following thermal decomposition reaction? You are given the atomic weight of Cr is 52 unit, for Ba it's 137 unit. Any idea how to solve it, guys? Any idea how to solve it? Come on. Anybody? No one? Hello. I think everybody slept off. It's about to be 8:30 and in Bangalore it's raining, so you all slept off, huh? Guys? Chalo, let's do it. Okay. So the first reaction is 2NH4NO3 solid N2 4H2O plus O2. Okay. So let's write it down. 2NH4 NO3 gives 2N2 plus 4H2O plus O2. Now from here I can see that 2 moles of NO3 gives 2 moles of N2. Am I right? Am I right, everybody? Are you all able to understand my handwriting? Are you guys able to understand my handwriting? Now, what is the molar mass of NO3? It's about 80 gram per mole. So that means if 2 moles of NH4NO3 gives 2 moles of N2, that means 80 gram of NH4NO3 will give us what? Network issue. Not able to watch me or what? So 80 gram will be giving us 1 mole, right? Okay. So that means if I write now 1 gram of NH4NO3, calculate this. Calculate this, everybody. Calculate this, guys. Calculate this. Calculate this and tell me what is 1 by 80. Chalo, no problem, no problem. Acha, next, let's take it. You calculate this, okay? 1 by 80, you calculate. Now let's take BaN3 by 2 gives Ba plus 3N2. What do we see? We see that 1 mole of what is the molar mass of 0.0125, okay? 0.0125. Okay. Now, what is the molar mass of BaN32? Calculate, calculate, calculate. You are given also. See, Ba is 137. 137 plus N32. It will be around 221. So that means that it will be around, yes, 1 by 221 into 3. Now calculate this, that is 3 by 221, calculate it. So like this only you have to do it for NH42Cr2O7 as well as you have to do it for 2NH3. Now I know the answer. The answer is going to be option D here. If you calculate it for all of them, okay, if you calculate it for all of them, you will find that the answer is option D. Answer is option D. Chalo, but let's try to do it, okay. NH42Cr2O7. Or will you be able to do it, guys? Shall I give it to you as an assignment? Can I give it to you as an assignment? Will you be able to do it now that I've showed you how to do it? So basically you just have to find out, you have to calculate the molar mass and then you have to just divide it like this. Will you all be able to do it? Will you all be able to do it? If I give it to you as an assignment or no? Chalo, anyway, I think you do it as an assignment. I'll be giving you the PDF. Try doing it on your own, okay? And with this note, we are ending the session here today. Also, I think it's about to start raining and I have to rush home. Otherwise, I will not be able to go home. I will not find any vehicle. So I'm going to stop the session here today. I will see you very soon, okay? I'll see you very soon. And we will be very soon starting with the one-shot videos as well, okay? So stay tuned to the channel. I'll see you all very soon. Tata, bye-bye and good night. Bye.